Hi, good morning one and all. So last class we discussed about the bioavailability and the bioequivalence. So how to measure the bioavailability, that is we discussed in the last class. We have the various methods like plasma level time studies and urinary excretion studies, therapeutic response method and pharmacodynamic methods. This we discussed in the last session. Okay, so today we'll go through the drug dissolution rate and bioavailability. So the last class we discussed methods were the in vivo methods for determining the bioavailability. Even though bioavailability is exactly the amount of drug reached into systemic circulation, we can determine the same or we can predict the same with the help of certain in vitro methods. So the dissolution is a supportive test in order to predict the bioavailability. In other way, we can say it is an in vitro method for determination of bioavailability. How this dissolution help in this? So in this section we'll look into what is dissolution, what are the various dissolution apparatus, what are the criteria for dissolution, and how to compare the dissolution methods. This is what we are going to listen here. First of all, dissolution, we did the practicals of dissolution, many practicals we done. So dissolution is a general definition. How do you define dissolution? That is, it is a mass transfer of solute into the solvent system. Transfer of solute molecules into the solvent system. We call it as the dissolution. In the first chapter, absorption, you learned a rate limiting step. That is the process that limit. The slowest process that limit the absorption we consider as the rate limiting step. So for absorption of a drug molecule, initially it has to dissolve, then it has to penetrate. So solubility and permeability are the two terms we discussed to define the rate limiting step. In case of an orally administered drug molecules, even though the drug is permeable, solubility is an important aspect. If the drug is least soluble, we can predict that it is least absorbed. So how this dissolution can predict the bioavailability? The concept is this: if the drug is easily permeable, if it is dissolved, such a rate limiting step is nullified. As the time for dissolution increases, the process or the probability for increasing or probability for a high bioavailability is less. If it's easily absorbed, if it is easily dissolved, if it is easily solubilized, the Tmax will be very less. We can predict a more better bioavailability. So this is the concept behind determination of or prediction of bioavailability based on the dissolution. So generally dissolution can be done in three type of methods. The first one is a closed compartment apparatus. The second one is an open compartment apparatus, and third one is a dialysis system. So this is not similar to that of the compartment model what you have learned. First of all, that you keep in mind. A closed compartment means it follows a non-sink condition. What was non-sink condition? Sink condition means there is continuous flow of fluid. Body is an example of sink condition, because an absorbed drug molecule is continuously flowing throughout or it is distributing throughout the body. It is not localized in any part of the gastrointestinal tract. It is absorbed in systemic circulation. Within the systemic circulation, it just distributes. At the same time, it metabolites and eliminates. So this is an example of a sink condition. So whereas in case of a non-sink condition, in example there is dissolution apparatus. So dissolution apparatus, if you put the 100 mg of drug also, if this 100 mg will remain within the dissolution fluid. If it having a 500 ml dissolution fluid, it can dissolve only in this maximum 500 ml. It cannot dissolve beyond that. So that is a non-sink condition. Previously, the dissolution apparatus was only a non-sink condition, but again, in order to mimic the body conditions, we developed a dissolution apparatus with the sink conditions also. Dissolution apparatus with the sink condition. So that it is an in vitro test, it is an in vitro dissolution process. At the same time, we are maintaining a sink condition similar to that of the body. So a closed compartment maintain a non-sink condition, an open compartment maintains a sink condition, and we have a dialysis system. So these dialysis systems are used especially for very poorly solubilized drug molecule, which again the speciality of the dialysis system itself is it maintains a sink condition. So these are the different types of apparatus, general classification of the apparatus. So what are the factors to be considered for designing a dissolution test? So it depends on the factors related to the dissolution apparatus, factors relating to the dissolution fluid, and the certain process parameters. Now what are the factors relating to the dissolution apparatus? You know, different type of dissolution apparatus. For the practicals you have come across the USP type 1 as well as USP type 2, basket as well as paddle. And you know, the size of the vessel. The vessel, it was in the bottom of the vessel, it was a round. It is not a flat one, it is a round one. The size of the container is important here. What is the RPM you are using? So these are some of the RPM means the speed of rotating the paddle or basket, whatever it is. So these are some of the conditions of the dissolution apparatus what we are selecting. What is the type of apparatus? So generally we have 6 type of apparatus. You have seen only 2 type of apparatus. So selection of the apparatus and the basket, the jar, the paddle, the speed of the dissolution. So these factors vary from product to product. At the same time, these factors can affect the dissolution of the drug product. So that is the reason for a specific drug molecules we can specify some of the apparatus. So it is not common that for all the tablet you have to go with the dissolution type 2, or all the capsule you have to go with only dissolution type 1. It's not like that. Based upon the nature of the drug molecule, based upon the nature of the dosage form, the selection of the dissolution apparatus vary. So these are the factors related to the dissolution apparatus that can contribute towards the dissolution of the drug molecules. The second one is the dissolution fluid. Always the dissolution fluid is something, a fluid that mimicking your gastrointestinal system. So we have an acidic pH, we have basic pH. Are similar to that of we can select an HCl with an acidic pH or a phosphate buffer with a basic pH. Then volume of the buffer varies. At the same time, apart from this, we can have a simulated gastric fluids and simulated intestinal fluids, which may have some other proteins or diet factors, enzymes, etc. incorporated into the dissolution media. That again will act as a supportive system for the dissolution. So the first chapter, the factors affecting the absorption, you learn the gastric contents. Hope you remember the gastric contents can support or it can deny the absorption or solubility of the drug product, like carbohydrates, proteins, fats, etc. can affect the dissolution. So in the dissolution fluid, if you generally consider, we have either an acidic pH or a basic pH, an HCl or buffer. This may not have a gastric content. It may not have any of the food items. So in order to mimic the body conditions, we can select the gastric fluids, we can select the dissolution fluids simulated to that of the gastric fluids or simulated to that of the intestinal fluids. Generally we are adjusting only the pH. Apart from the pH, the content of the gastric environment can be brought into the dissolution media. The content of the gastric as well as intestinal fluids can be brought into the dissolution media. So we call it as a simulated gastric fluids or simulated intestinal fluids. And the third one is a process parameters. That is the process of how you are introducing your drug molecule into the system and what rate you are sampling, what is the volume of sampling, at what frequency you are sampling, and how you are changing the dissolution fluid. So these are some of the temperature. So these are some of the process parameters that can affect the dissolution. So the dissolution of a product depends on the factors related to the dissolution apparatus, factors related to the dissolution fluid, and certain process parameters. Now, I told you there are 6 type of apparatus, or you can say 7 type also. The 7th one is some of the accessories. Generally we have 6 apparatus now. The first apparatus is the USB type 1 basket. The second apparatus is USB type 2 paddle. Third one is apparatus 3 is reciprocating cylinder. Apparatus 4 is flow through cell. Apparatus 5 is disc paddle over the disc. Apparatus 6 is cylinder, and apparatus 7 are the reciprocating holders. Now we'll look into one by one. We have 6 apparatus or 7 apparatus, as I said. Selection of apparatus is based upon the nature of dosage form as well as nature of the drug molecules. Some drugs will be least soluble, highly soluble, or poorly soluble. Some dosage forms may be least soluble, some will be controlled release, some will be transdermal, some will be immediate release, some will be capsules. Based upon the type of the dosage form and based upon the physicochemical nature of the drug, the selection of the apparatus varies. The USB type 1 paddle is highly used for capsules as well as some of the floating tablet. So capsules, if you put into the dissolution media, it will float. Some of the tablet also has a floating tendency. So if it float, the effective surface area, the surface area that is exposed to the dissolution fluid, the effective surface area may reduce. It may affect the dissolution. In order to maintain the proper surface area, the dosage form must sink inside the dissolution media. This is done with the help of the USB type 1 basket. The second one is the USB type 2 paddle. This, by using the paddle, you have already performed the dissolution of the paracetamol tablet. The paddle is inserted into the dissolution vessel, followed by we are inserting the tablet. In the case of USB type 1 basket, inside the basket we are taking the dosage form. The basket, inside the basket you put the dosage form, then the basket is inserted into the dissolution vessel and the basket is rotating. Whereas in the case of paddle, the dosage form is inserted into the dissolution jar where we are taking the dissolution fluid. To this jar we are inserting the dosage form and the paddle is rotated. So generally all type of dosage forms dissolution study can be done by using the type 2 paddles. The third one is the reciprocating cylinder. In the first and the second apparatus, the paddle or the basket is rotating. In the third one, by name itself, it is a reciprocating cylinder. So it has a jar, first of all, it has a cylinder, and the speciality of the cylinder is it is reciprocating. It is up and down movement. The previous one, the basket, it is rotating. Here it is a cylinder. Instead of the basket, it is a cylinder. The cylinder is reciprocating, that makes up and down movement. The basket you seen, it is made with a mesh. The cylinder here, what the difference is, it is bigger than that of the mesh. I don't know whether you have seen the disintegration apparatus in the third year of the third family or not. Disintegration apparatus always make an up and down movement. It is made up of glass also. basket made up of mesh, whereas reciprocating cylinder made up of glass, whereas its top and bottom is open, and this makes a reciprocating movement. So the dissolution jar is comparably lesser than that of the type 1 as well as type 2 for a reciprocating cylinder. So this reciprocating cylinder is highly used for dissolution study of controlled release formulations. The fourth one is flow through cell. Flow through cell. Flow through cell is also highly used for poorly soluble drugs as well as granules or whatever it is, very poorly soluble drug molecules. So this is an example of your dialysis system or an open compartment system. So what happens? Poorly soluble drugs required more amount of dissolution fluid. If it follows a sink condition, the solution will be saturated very fastly. If it's saturated, further dissolution will not happen. So we need to prevent the saturation of the dissolution fluid. So what happens here? In order to prevent the saturation of the dissolution fluid, a fresh volume of buffer is always pumped into the dissolution jar. So this is a flow through cell. If you put a tablet inside the flow through cell, the dissolution fluid is always running. A fresh dissolution media, the tablet is always exposed to fresh dissolution media. Whereas in the previous, all the three dissolution apparatus, if you take 500 ml dissolution media, till the end of the dissolution study, the media is a constant one. The media we are not changing. Whereas in the case of flow through cell, fresh media, the tablet is exposed to fresh medias. The next one is apparatus 5, that is paddle over the disc. Paddle over the disc. The apparatus is same to that of apparatus 2. It is a dissolution jar is there of 1 liter capacity. It has a dissolution paddle is there, and apart from that a disc is placed at the bottom of the dissolution jar. So this apparatus helps to conduct the dissolution study of transdermal patches. The apparatus 5 and apparatus 6, both these apparatus are used to perform the dissolution study of transdermal patches. The speciality of transdermal patch, what it is, we are setting or we are fixing the transdermal patch into the surface of the skin. So whereas in case of tablet means we are consuming it, undergo all the processes what is happening in the stomach. In case of patches, there is no such process. The patch is a stagnant one, the patch is a constant one, and the drug is releasing from the patch. So the patch what we are using can be pasted over onto the either the disc or the cylinder. Either the disc or the cylinder. So the patch that is pasted into the disc, it is a constant one. The paddle is rotating. The paddle make agitation for the dissolution fluid, and it maintains a sink condition. Sink condition means it never attains a saturation. There is a mixing of released drug happens throughout the dissolution fluid. The transdermal patches pasted over the disc or the cylinder, slowly with the help of the dissolution media, it releases the drug into the dissolution media, while the paddle or the cylinder, when it rotates, it mixes the drug molecule within the dissolution fluid. That is the speciality of apparatus 5 and apparatus 6. And apparatus 7, these are some of the reciprocating disc, spring holder, Teflon cylinder, acrylic rod, and angle disc, etc. So initially I said this is not exactly a separate apparatus. If you consider another 6 are like an apparatus, whereas the 7th one is some accessory. These are the accessories when a specialized dosage form, suppose if it floats, a dosage form, it floats only for some period of time, and the remaining time it will sink within the dissolution media. So that time we cannot select the apparatus 1. example, we cannot select the apparatus one basket because this dosage floats only for some period of time. So this is an example of that one. We can use some of the accessories in order to sync or in order to act in the time of the floating, so that at that time alone it will sink inside the dissolution media. That is the thing. So these are accessories can be used along with any of the above mentioned dissolution apparatus. So these are the 7 dissolution apparatus. Here are the 7 apparatus along with the drug formulation. What are the functionalities of the dissolution apparatus? This also you can go through when you are listening, when you get the free times. Okay, this is exactly what is given in your textbook. This is another picture of dissolution apparatus USP3, that is reciprocating cylinder. So the first one what you are listening is the dissolution jar. Inside the jar there is one more small cylinder with a less diameter than that of the dissolution jar, that is connected to the upper gasket. This gasket is making the up and down movements. This is a picture of flow through cell. The speciality of this flow through cell in the bottom, this is something like a conical in shape. The bottom is conical in shape. Inside you can see the tablet is placed. In the bottom of the conical part, the tablet is powdered and powders are sedimented in the bottom. So in the flow through cell, the flow of dissolution fluid continuously happens from bottom to top. There is a circulation, or there is a replacement of dissolution media happens in the flow through cell. This is a USP type 4. And this is exactly another picture of paddle over the disc which was given the measurement. This picture is not of major importance. It's exactly same as that of the previous one what you have mentioned. Now we just listen. You have completed the dissolution apparatus. What are the types of dissolution apparatus is over now. Now we perform the dissolution. Now we got the result. How do you judge the dissolution is right or wrong? For example, you did the dissolution of paracetamol tablet for the Bioavailability practicals. Some of you got 60% dissolution 30 minutes. Some of you got 45%. Few got only 15%. And some got 80%. Among this, which is right? How do you evaluate? How do you judge the result? The dissolution result is right or wrong? This is judged based upon the acceptance criteria. Okay. Acceptance criteria, we have a prefixed value. That is value is known as a Q value. Q value, capital Q. Q value is a constant value, and Q value varies from drug to drug. Paracetamol has a specific Q value. Diclofenac has a different Q value. Metformin has another Q value. Q value varies from drug to drug. Q value is a value that mentioning the percentage of drug dissolved at a specific period of time. Percentage of drug dissolved at a specific period of time. For example, for a particular drug molecule, Q value is 80% in 30 minutes. Some of the drug it will be 90% in 25 minutes. This means what? In 25th minute, it must dissolve minimum 90%. It can go beyond 90%, but it should not be less than 90%. So Q value is 25 minute 90% or 30 minute 80%. Q value never stands as a percentage alone. It will be stand along with percentage and time. The percentage will stand along with the time. At this time point, this is the Q value. That is the specialty. we cannot say that Q value is 80% at what time point. It is specific. Okay, so that is the Q value. Now the second thing what you have to remember here it is, any of the test we are performing, we should not perform in a single unit. We have to do in a multiple unit. So for dissolution acceptance criteria, we have three different stages: stage 1, stage 2, stage 3. So in the column in the display, you can see S1, that is the stage 1, S2, that is the stage 2, S3, that is the stage 3. In the stage 1, first when you are going to perform the dissolution of a tablet, you can perform the dissolution with a 6 tablet. So 6 tablet of same brand, same 6 tablet of same batch. You put it for dissolution. That is n is equal to 6. So the acceptance criteria is no dosage unit is less than Q plus 5%. I said 3 different stages are there. The first stage you will perform with 6 tablet. If it fails in the first stage, you have to go to the second stage. In the second stage, you will perform it with another 6 more tablet. Okay, so first stage 6 tablet. If it passes, that's fine. If it fails, you have to perform the second stage dissolution, that is with another 6 tablets, and then you can merge the result of 6 tablet of the stage 1 and the 6 tablet of the second stage. So at the second stage, if it passes, if it's accept or it is within the acceptance criteria, that passes. If it fails the acceptance criteria, this goes to the third stage. In the third stage, you have to perform 12 tablets. You have to perform dissolution of the 12 tablets. We can merge the result of the previous 2 results also and compare with the acceptance criteria. And if it passes the acceptance criteria, it's okay. If it fails, means the batch is considered as failed for dissolution. So 3 stages: stage 1, 2, 3. Stage 1, 6 tablet. If it passes, it clears the dissolution. If it fails, it goes for the stage 2. We'll perform with another 6 more tablet. If it passes, fine. If it fails, means again you have to go to the stage 3 of dissolution. There you have to perform with the 12 tablets, and you have to compare with the acceptance criteria. Now the acceptance criteria for the 3 stages are different. In the first stage, what is the acceptance criteria? That is, no dosage unit should be less than Q plus 5. That means if the Q value is 80% in 30 minutes, if Q value is 80% in 30 minutes, no unit should be less than Q plus 5. That means all the 6 tablet must dissolve 85% in 30 minutes. That is, Q value is 80%. Q plus 5 means 80 plus 5, 85. So at the 30th minute, all the 6 unit should give how much? 85%. That it is not the average value. 6 tablet must give 85%. It is not the average value in the case of stage 1. Okay, so if all the 6 units gives 85%, it passes. And even one tablet also, if it is less than 85, say it is 83 also, it fails the stage 1. Then it goes to the stage 2, where we test the 6 tablet. Okay, so in this stage we can collect the average value of 12 tablets. 6 tablets we performed in the stage 1, 6 tablets we performed in the stage 2. Take the average of 6 plus 6, 12 tablet. So the average of 12 tablet of stage 1 and stage 2 should be greater than Q percentage. That means in the stage 2, it should be greater than Q percentage. That means it should be greater than only 80% in 30 minutes. Okay, average of 12 tablets should be greater than Q percentage. Okay, and no dosage unit should be less than Q minus 15. So here we are considering the average value. It is a failed in stage 1. That means the tablet is having some issue. it failed in stage 1 and you are performing in stage 2. Stage 2, two conditions are there. First condition, the average of 12 should be greater than a Q value, 80%. Second thing, none of the unit, 12 units are there, none of the units should be less than Q minus 15. Q minus 15 means it is 65. 80 is the Q value, 80 minus 15, that is 65. No unit should be less than 65%. So here we are considering the average value. Average of 12 must be equal to or greater than 80, and 12 tablets, none of the tablets should be less than 65%. This is the acceptance criteria for stage 2. Okay, and in stage 3, now if it fails in stage 2, it goes to the stage 3. There we have to perform the dissolution of another 12 more tablet, and the average of stage 1, stage 2, stage 3. Now we have 24 tablet, the result of 24 tablet. Okay, here the acceptance criteria is more liberal. The Q value are not more than 2 dosage units are less than Q minus 15. So the average of S1, S2, S3 must be greater than Q value. If it fails, if it is 79% also, it fails the stage 3. The average must be greater than 80%. First condition. Second condition, not more than 2 dosage units are less than Q minus 15. And third condition, no dosage unit is less than Q minus 25. Q value is 80, Q minus, example on Q value is 80, Q minus 15 is 65%. So we have 24 tablet. Out of this 24 tablet, 22 tablet must be greater than 65. Maximum 2 tablets can go less than 65. That is, and not more than 2 tablet dosage units are less than Q minus 50. Okay, so out of 24, 22 tablet must be greater than how much? 65. Average must be greater than 80. First condition, Q value. Among the 24 tablet, 2 tablet can be between 65 to 80, and 2 tablet can be less than 65. That 2 tablet must be more than Q minus 25. Q minus 25 means that is 55. So that should be greater than 55 also. അപ്പോൾ സിമ്പിളായിട്ട് പറയാം, 24 ടാബ്ലറ്റ് ഉണ്ട്. 24 ടാബ്ലറ്റും ആവറേജ് എന്ന് പറയുന്നത് 80-ൽ കൂടുതൽ ആയിരിക്കണം. 80-യോ 80-ൽ കൂടുതൽ ക്യൂ വാല്യൂ കൂടുതലോ ആയിരിക്കണം. ഇവിടെ ഞാൻ 80 എന്ന് പറയുന്ന എക്സാമ്പിളാണ്, 80 അല്ല ക്യൂ വാല്യൂ. എക്സാമ്പിളാണ് ക്യൂ വാല്യൂ 80 എന്ന് പറയുന്നത്. 80 കൂടുതലായിരിക്കണം. പിന്നെ 2 ടാബ്ലറ്റിന് മാത്രം 80-ക്ക് താഴെ പോയാലും 2 ടാബ്ലറ്റിൽ കൂടുതൽ ഒരു ടാബ്ലറ്റിന് പോലും 65-ൽ താഴെ പോകാനായിട്ട് പാടില്ല. അതായത് 22 ടാബ്ലറ്റും 65 എബോവ് ആയിരിക്കണം. 2 ടാബ്ലറ്റിന് മാത്രം 65 താഴെ പോകും. ആ 2 ടാബ്ലറ്റിനും 55-ന് എബോവ് ആയിരിക്കണം. അതായത് 45-ഓ അല്ലെങ്കിൽ 54-ഓ വരാനായിട്ട് പാടില്ല. 54 വന്നാൽ ഫെയിലാണ്. അപ്പോൾ 2 ടാബ്ലറ്റ് ക്യാൻ ബി എബോവ് 55. Then remaining all the tablet must be greater than Q minus 15, and the average should be greater than Q. This is the criteria, acceptance criteria for dissolution. Now the next topic is method for comparison of the dissolution profile. So you have if you consider a single drug molecule, variety of marketed products are available. Okay, this comparison has a story. Now it's not like a story. This is for comparison of bioequivalence. So what is bioequivalence? Everything I will say you in the next session, the third session that I will introduce in the next day. Okay, there I will explain exactly what is bioequivalence and all. and what is the necessity for comparison of marketed products, etc. I will explain in the next session. Now, for the comparison of the marketed products, if you take diclofenac available in multiple brands. If you want to compare the brands to brand, we can use the dissolution profile. So an innovator product or a standard product will be there. If you want to compare your test product with the markedly available standard product, you can use the dissolution comparisons. Okay, to compare the dissolution, two factors we are considering, that is a difference factor as well as a similarity factor. Similarity factor shows the similarity between the test and standard. Difference factor indicates the difference between the test and the standard. In order to determine the similarity factor and the difference factor is indicated as F1 and the similarity factor is indicated as F2. Difference factor indicated as F1, similarity factor indicated as F2. So below it is mentioned the equation for F1 and F2. Suppose I just tell you how to perform this. Okay, suppose you are having dissolution from 1 to like every 10 minutes you have a dissolution time points, 10 minutes, 20 minutes, 30 minutes, 25 minutes, 30 minutes, whatever it may be. Okay, each time point you have to compare the difference factor of test as well as standard. For the determination of the difference factor F1, this is the equation. For the comparison of difference factor F1, here is the equation. F1 is equal to sigma t equal to 1 to n RT minus TT. RT is the reference at a time point. T, small t represents the time point, capital T represents the test, capital R represents the reference. Small t is the time. So dissolution, percentage dissolution of reference in the 10th time point. With the example of 10th time point, we are going to determine the difference factor in the 10th time point. So dissolution percentage in the 10th time point minus dissolution percentage of the test at the 10th time point, that is RT minus TT. Okay, the all divided by RT, that is reference into 100. So this gives the value of F1, and here is the equation for F2. It's a little bit complicated one, not a complicated one. It's a few more steps are there to perform. Here also nothing, you have to substitute the value. The variables n indicates number of tablet. Okay, how many tablet you perform the dissolution, that is minimum 6 tablet ആണ് പറയുന്നത്. So if it is 6 means n is equal to 6. Okay, so variable n is only the new factor here. N is the number of tablet, RT and TT are the reference and tested at the time points. Square കാണണം, പിന്നെ raised to 0.5 കാണണം, minus 0.5 multiplied with 100, and you have to take the logarithm and multiply with 50. You will get a value of F2. Okay, so sorry, here the n is the number of dissolution time points. N is the number of dissolution time points. Now you got F1 and F2. How to compare this F1 and F2 now? So this is the table which is comparing the F1 and F2. If the difference factor F1 is 0 and F2 is 100, the product is purely identical. Whereas the difference factor F1 is less than 15 and the similarity factor is greater than 50, that it is 55 also. So greater than 50 up to 100, it is similar or equal in profile. If the values are beyond, if the difference factor is greater than 15 and the similarity factor less than 50, it shows the product is different. That's it. Okay, so difference factor 0 and similarity factor 100 means the product is purely identical. Difference factor less than 15 and similarity factor greater than 50, the product is similar. So these are the things. Now this is determined based on some of the conditions, that is minimum 3 dissolution time points you have to measure. 3 dissolution time points. Maybe performance may be collected the sample from 0 to 60 minutes in every 10 minutes interval, 10, 20, 30, 40, 50, 60. even though you have performed for the 6 time points, minimum 3 time point you have to consider for comparison of dissolution profile. That means 20, any 3 time points, maybe 10 minutes, 30 minutes and 60 minutes. At the 3 time point, it should have a uniform result. At the 3 time point, if it shows a similarity factor shows 100, it is identical. If it is beyond 50, it is similar. That's it. The number of drug product tested is 12 for test and the reference. Number of drug product, that means minimum 12 units must be tested, and not more than, actually generally for general purpose for determination of dissolution we are performing 6 units, but for calculation of similarity factor and differential factor it should be minimum of 12 units and not more than the mean value of greater than 85% dissolved for each